Okay, last. But I think so. Okay, so once we identify, it's really helpful seeing that bracket squared. So then we can clearly see, okay, there's a bracket squared. I got to do power rule from my outside component. And then my inside component is that cosine of 4x. And I take turns with each derivative. Outside portion, bracket squared becomes 2 brackets to the first power. And then we move on to cosine of u's derivative, which is negative sine of u times u prime. That completes our derivative. Number 2, rewrite it using rational exponent. And then remember, you can take advantage of log properties rather than going through u prime over u at this stage and having to go through additional chain rule. Once that 1/2 comes down, then a lot easier without having to go through chain rule. So take advantage of log properties, and then your derivative is going to be a lot easier. Okay, number 3, x cubed plus 2y to the 5th equals 10xy. We need to be able to recognize this as, okay, there's a need for implicits because multiple y variables. And what do you notice about that 10xy? There's also, what else do we need besides power rule and implicit? 10x times y, we got to do away. Product rule, yeah. Notice that you have 2 y variables in the equation, which means that you should be expecting 2 dy dx's to show up in your derivative process. Once we're once we applied our derivative, the rest is just algebraic steps. We're just moving things around, trying to eventually isolate that dy dx. So I like to group my dy dx terms on the left side, and then factor dy dx out, and then they don't have to simplify. I factored a 2 out and simplified, but I'll accept a non-simplified expression as well. Okay, number 7, inverse cosine of x cubed is same as arc cosecant of x cubed. So think about your derivative rule for arc secant related to your arc. Sorry, arc cosecant is related to your arc secant. It's the negative version of your arc secant. Five and six, this is where you are creating your charts, moving your way around that chart, knowing that there's a relationship between a function and its inverse, order pairs are flip-flop, and then the slopes at their corresponding points are reciprocals of each other.
On number 4, you have to simplify the x squared and the x cubed for yeah, you have to reduce it to
Oh, reduce it. I'll prefer that you reduce it if it's relatively reasonable. But if something is more complicated where you got to do a bunch of individual fractions and you don't want to find common denominators, and then you can leave that alone. Yeah, but I want us to practice getting it relatively reduced so that because there's multiple choice on AP exam, this is what your answer will look like. So to begin number 5, you can get to this stage even without looking at the rest of the problem. You know that you're looking for g prime of -1, which is the bottom right corner. You know -1 is the x value of your g function, which must mean -1 is the y value of your f function. And then you should be able to start with that, begin with that, and then start filling in your numbers around the chart. For number 5, we know that the order pair on the F side that has a y value -1 must be involving 6 -1s. So once you can figure out the order pair 6 -1, you know G side must be -1, 6. And because 6 is the X value on the F side, you know if you can find F prime of 6, that's going to lead you to G prime of -1 because these are corresponding points. So a slope of 3 will lead me to a slope of 1/3. Any questions with 5? All right, number 6, same process. Sometimes the problem may ask you to do guess and check, but in this case, they give you the order pair that you're going to need. So there's an order pair -3, -1 that lives on a G function. There must be an order pair -1, -3 that lives on F. If I can find F prime of -1, I can find the slope of the F graph at -1, that number will lead me to my answer. So find F prime of X first, find the slope at that point, and then just take the reciprocal. Make sure you don't change the signs. You're just flipping the fraction, flipping that value, but the sign is going to stay the same. Okay, move on to page 2 if you're ready. I'll come around and see if you guys have any questions as you're working through. Yeah, so your answer would be the same as mine. If you distribute a negative through your answer and got the same as mine, then it's the same thing. Just make sure you distribute negative to the top and bottom. If it does, then that's fine. If you see the notation d2y over dx2, that means you want to find the second derivative. And when I ask for the second derivative, and your if dy dx is popping up, make sure that you replace, you can represent your second derivative purely in terms of x and y. So if there's dy dx is left over in your second derivative, you're going through and making additional substitution to get your answer just in terms of x and y. So number 8, we require implicit to get to our dy dx. Again, you can see y just by itself. I think it's really helpful to put a 1 as you build your dy dx as a reminder later on that when you factor that dy dx, that there's still a 1 that's going to be a placeholder for that term. So y becomes 1 dy dx, y squared becomes 2y dy dx, x becomes 1. Move terms around, solve for dy dx, I get 1 over 1 minus 2y. So this is halfway, at the halfway point, we want to find the second derivative. You can go through quotient rule, but I find it easier, especially if my numerator is just a constant. I like to move it up to the top and just rely on chain rule. This feels a little bit less messy. So from here, I'm going to find the derivative again. I got to go through chain rule here. Outside times inside derivative. Bring the -1 down, subtract 1 from the exponent, multiply by the inside derivative. Now 1 minus 2y becomes -2, but we're still asking for y's derivative, so we still need to attach that dy dx. So we're pretty much at the answer here. Now we're just trying to get this cleaned up. So let's replace the dy dx back with something in terms of x and y, or in this case, in terms of y. And then once I make that substitution and I do some cleanup, I can do some merging of the denominator to get it 2 over 1 minus 2y. Any questions with 8? Okay, number 9, find the equation of the tangent line. So you know there's implicit involved, but once you get to dy dx, you can plug in the ordered pair to get your slope. And then once you have your ordered pair and your slope, then point slope form will get you to your equation. Any questions with 9? Ten's a little messier because we have to make our way to the second derivative. In doing that, you got to go through implicit twice, and then you have to plug in 0 and -1 into the second derivative to get your second derivative value. So let me walk through number 10. So x becomes 1, y squared becomes 2y dy dx, cosine becomes negative sine. I'm just trying to solve for dy dx, and this is my halfway points. Dy dx equals 1 minus sine x all over 2y. Okay, so now we want to find the derivatives again to get the second derivative. Notice in this form, I got to go through quotient rule, and then I have to also involve implicit because there's a y stuck in my equation. So I got to go through quotient rule, f prime g minus f g prime all over g squared. So here's my f prime g minus f g prime all over g squared. As I go through g prime is 2 dy dx. The advantage for this problem is that it's not asking for the second derivative function. It's only asking for the second derivative value. So we don't have to replace the dy dx with the whole expression. We can just go, because we're already at the second derivative level. Now you're just trying to plug in all your x and y values to just get it down to a number. Okay, so you can save a little bit of time here. So at this point, my dy dx, let me just go ahead and define my dy dx as 0, -1. So if I dy dx, if I plug in 0 and -1 for x and y, I can just get a slope value, and that -1/2 can just replace my dy dx. And then all your x and y values gets replaced with 0 and -1. And now you're just off to just trying to get all these numbers cleaned up down to a numeric value. So on my key, I kind of ran out of space, so I put my work below number 11. Number 10, find the equation of any horizontal tangent line. So ultimately, this means that once you find your dy dx, you're just setting your numerator of your derivative equal to 0. So horizontal tangent line is setting the numerator of the derivative equal to 0 and solving for the variable. And then your vertical tangent line is found by setting the denominator of your derivative equal to 0. So for 10, I have to go through chain and implicit, get my dy dx to show up, solve for dy dx. And then I know that my solution is going to be found by setting the numerator equal to 0. So if I set my numerator 2x plus 4 equals 0, I get x equals -2. Now I'm looking for a horizontal tangent line. So I'm basically I'm solving for y. I need a y equals to create that tangent line. So once I have x equals -2, I haven't found my y yet, but I can plug that x value back into my original equation and solve for y. And once I have solved for y, then I have my tangent line equation. So sometimes if you set your numerator equal to 0, you may still not be at the variable that you need, but you're just one step away from getting to that, because if you have one variable and not the other, just plug it back into the original equation to find your other variable's value. Number 11, find the slope of the tangent line. So you got to find G prime. Careful, all these trig functions with that exponent in that abbreviated form, make sure you pull that exponent outside a set of parentheses. Otherwise, it's a lot harder to see the need for chain rule or apply the chain rule correctly. So get that 3 outside a set of brackets first. And then it'll be a lot easier to see, okay, there's an outside portion. I got to deal with that 4 bracket cube first. Get that power rule derivative first, and then worry about the inside components derivative. And then I can replace all your x values with power 4. Now, this, we definitely have to go one step further. Okay, you cannot leave your answer with a trig value. You have to get it down to a numeric value. Now, once you're here, once you're down to these fractional values, you can stop. This is good enough on the AP exam. But if you leave it as cosine of power 4, sine of power 4, that's not far enough. You got to get it down to a unit circle value before you can stop. Any questions with page 2? All right, go ahead and start page 3 if you're good with page 2. All right, so your homework is you guys finished page 1 and 2 of your review packet. I just want you guys to go back to finish unit 3 packet, page 30 and 31. And then tomorrow we'll work on page 3 and 4. And if we finish that, I'll come up with some more practice problems that we can do. So I think between today and tomorrow, hopefully that will be, you'll feel relatively ready for your test. You have the weekend to study, you have Monday to study. We do need to start our next unit on Monday, which obviously won't be on the test, and your test will be on Tuesday. Help session. I'll have a help session tomorrow morning and Monday morning. Okay, I'll send out a reminder. I'll send out a reminder about your homework tonight.
And so when I did, instead of simplify here, I brought this down.
The problem is that if you want to bring that down, you first have to merge this to be a frame fraction. This term is attached to the minus sign, so we can drag that denominator to this number. But you can't simplify, you simply find a common denominator first, merge this into one fraction, and then you can put that denominator with this denominator.
So you have to merge, so that has to be less.
Right. You can make it.
Now I can bring that up. But I'm trying to find out.
If you didn't take anything, actually, you would
Make it spot. Alright. Then you have to see.
James.
Thank you.
You think it's good book?
Yeah.
Oh, yeah, oh,
Yeah, which one are you taking?
Remind me tomorrow.
Everyone say this. Have you done your interview? Yes, do an interview. You sit in front of the class and ask us 10 questions from a sheet of 58. Are you got usually a suit? No. Are you?
I didn't.
I'm wearing khaki or a clothing.
Thanks, industry.